Let's go over a couple of ways we can get different devices to communicate with each other. An old school way of doing it, but definitely still used in industry, is serial communications. This is usually done in the form of RS-485 or RS-232. The most popular protocol in industry that uses this is Modbus RTU. For serial communications, you need to use a particular type of screen cable, such as a Belden 3105A. This is the best way to make sure the data doesn't suffer from any interference. The other common method of communication is Ethernet. This method uses standard Cat5 or Cat6A cables. This method of communication is becoming more and more the norm in industry, not only because it's easier to set up, but it's also much faster than serial communications, which not only allows devices to transfer more data, but they transfer it at a much quicker rate too. In the case of the two PLCs I've got here, by using communications, the Mitsubishi PLC can read the input of the Schneider PLC and activate an output based on this input data. And even though both devices are by different manufacturers, due to the nature of Modbus TCP being open protocol, both devices can use it. Not only can the Mitsubishi read the data, it can also write data, meaning that if an input activates on the Mitsubishi, it can write to a bit in the Schneider for it to activate an output. As I mentioned before, Modbus is an open protocol, meaning it can be used to read data from energy meters, remote I/O, or even inverter drives, due to the fact most industrial devices have Modbus capability. So that was a quick rundown of how to connect manufacturers of different devices together, how to make them communicate. Modbus TCP is a whole different topic in itself, as is Modbus RTU. If you want to know anything more about that, let me know down in the comments.